Alrighty, here we go, Module 6. You ready to take this algebra section by storm, I hope? Here we go. Get out your notes. Have a calculator ready if you want. And we're going to start in on Section 1 of Module 6 on Algebraic Expressions. Textbook pages we're going to cover are, I think, in this section, oh gosh, I think like 173 to 178, something like that. Today's assignment we'll get to at the end. We're also going to do some work in ScootPad, and depending on how things go, we'll see if I need some more things that I got to pull out of my little file cabinet. All right. So here's what we're going to do. All right. Back in your elementary school years, you worked on adding and subtracting, multiplying, and well, really dividing, but in some ways we like to think of it as factoring numbers, okay? And now what we're going to do is jump or leap into algebra land and start doing all of your operations with algebraic expressions. Okie dokie. So we had done some practice with the distributive property, okay? And so what I want to write down here, mainly because this is just your notes. Distributive property is written as a product, okay? Product being that math word that means multiply. So when I write an algebraic product, maybe I'll write something like this, 3 times, and then usually in parentheses, we have a quantity in here that has more than one term, like 2x plus 5 or something like that. So this is a product because I have this thing times this thing, but this thing right here has much more involved in it than just a single number. I have an algebraic expression. So we talk about how you have to take 3 times the first term, 2x, and 3 times that 2x will give me 6x. And then I have to take 3 times that positive 5, which gives me a positive 15. I have to leave that expression as 6x plus 15 because they're different terms. I cannot combine that into 21 anything. Nope. 6x plus 15. I often say this is like you and your siblings and you don't get along, so it's better just to keep you separate. All right, so think of it that way. All right, the other word we have in here is factor. So what I wrote in here first, as I looked at how your textbook went and defined it, they say to factor something is to rewrite something as a product. The other thing I'm going to write here, in a way, factoring is kind of a way to undo our distributive property. It's going to undo that distributive property. Now I'm going to abbreviate that and then I'm going to show you what I'm talking about, okay? And since these are your notes, I'm not going to get super uptight that they are, super grammatically correct. You just have to understand and be able to read them to use it as a guide to study. If I took the number 6 and I did this, does that look familiar? When you started breaking numbers up into their prime factors, you probably wrote something like this. 2 times 3. 2 and 3 are factors of 6. We took 6 and rewrote it as a product or as a multiplication program or problem. So what I'm going to do now that we're in pre-algebra, is we're going to take an algebraic expression like 10m plus 14. Let's do that. We can take this algebraic expression and break it up as a factor problem like this. Some number times, and I'm going to put big parentheses here. That's kind of like undoing the distributive property. 10 and 14 are numbers that share a common factor of 2. And if I factor a 2 out of the 10m, like dividing, you get 5m left over. Because see, if I redistributed, I'd get 10m. Factor a 2 out of the 14, you're left with 7. If you double check this again by redistributing, you would get 10m and 14. So basically, it's just undoing a distributive property problem, or you're undoing something and writing it as a product. Cool. Now, these two things basically are kind of covering what multiplying and factoring, or kind of like dividing, is. We need to talk about adding and subtracting. And so let's get into some of these examples, and I'll show you what we mean. Let's take a look at this example, which is in your textbook. Jill and Kyle get paid per project. All right. Jill is paid a project fee of $25 plus $10 per hour. Okay, stop right there. There's so much information going on. I have Jill and I have Kyle. Jill is paid $25 plus $10 for every hour she works. So I have to take 10 times every hour. I don't know the hours. That means this is a prime time to identify and define a variable. And since I like to be Captain Obvious, I'm going to use H for hours. I'm coming off to the side to that. So 10 times H is how much money she makes for the hours, plus she gets a $25 right-away fee. Okay, that's Jill. Kyle is paid a project fee of $18 plus $14 per hour. 14 times H, or 14H. Write an expression to represent how much a company will pay to hire both of them to work the same number of hours on a project. So if I've got both of them, I'm going to add them together. Jill's pay plus Kyle's pay, which means I'm going to come down and take this whole blob plus this whole blob. Now, some books will put parentheses, around here and say, here's Jill's rate, here's Kyle's rate, we're going to add these together. And that's fine. It's kind of actually nice to separate it that way. However, you now have trained your algebra eyeballs to so often look to see, oh, I've got to distribute something. But there's nothing in front there. Well, really, it's like a 1 times this, but distributing a 1 wouldn't change anything. So kind of, it's like these parentheses aren't really necessary. I have 25. I have a 10H plus, same thing here. There's nothing to distribute. So I really just have this whole string of 4 terms. And your job is to try to see, can you simplify? Well, if there's anything in common, we can. Look at this, 25. And then I'm adding an 18. I can rearrange the order thanks to the good old commutative property and rewrite this as 25 and 18. And then I'll put the 10H and the 14H back here. So all I did really was I just changed the order, and now I can say, hey, my associative property says I can group these two together and combine them now into one number. I can take these two terms together. Since they're like terms, they both have an H. I can combine those two together, but that's it. This has H's, this does not. Keep them separate. Now, as you get further along in algebra, usually we put something with a variable term first and then put the constant at the end. For today, frankly, I don't care what order you have it in. I just want to see a positive 43 and a positive 24H. All right, let's take a look at these examples now. I'm just adding two things together. two big old blobs, two big old algebraic expressions. When I'm looking at what's inside the parentheses and what's outside, I don't see anything to distribute. So really, I don't need these parentheses. You just have one big old string of 4 things to add together. And I'm going to rewrite the order because the commutative property tells me I can. 3x, a plus 7x, a plus 1/2, and then a minus 4.5. The associative property says group these bad boys together. Group these two constants together. Watch your sign. Now, some people like to write this as just 10x and minus 4. Some people might prefer to write 10x plus negative 4. Same thing. The minus sign is with the 4. So as long as you write it one of these ways, you're good. The 10x is positive. The 4 is negative. Boom. All right, let's take a look at number 3. On this first blob or first algebraic expression in these parentheses, there's nothing to distribute. I just have negative 25/100ths x. I don't put the 0 there. I'm lazy. Minus 3. Oh. You got to be careful here. Careful. Take a little break. This really does mean you have to distribute something because that minus sign with this implied 1 here, that's like saying you have to take negative 1 times that 1.5x. That becomes negative 1.5x. This becomes, instead of plus 1 4/10, that really means minus 1 4/10. So it's kind of like you're distributing or taking the opposite of every term inside that group in the parentheses. Okay, now I can rearrange the order as long as I understand that really I treat this as negative 25/100ths x. And then I think of this as like adding a negative 1.5x. As long as I keep that sign stuck with it, I can rearrange the order. This minus 3 is like adding a negative 3. So that can come next as a constant. And the minus 1 4/10 or negative 1.4, that's that last thing bringing up the caboose there, the last part of the train. All right, combine these two together and watch your signs. Combine these two together and watch your signs. That's as far as you can go. X, constant, can't combine. There you go. All right, let's talk a little bit more about the distributive property and what this means. In your notes, we accidentally forgot to give you this information about the tickets. So let's take a look at what's going on here. Mark is selling tickets for a high school band concert. The band gets to keep 25% of the money he collects from the ticket sales to put toward new uniforms. Awesome. Write an expression. Well, he gets 25%. I'm going to write that as a decimal times whatever the money is. Okay? Now, as I look here, there's a little bit more complexity to how much money we get from these tickets because the adults have one price and the youth have another price. All right? The adult tickets are $16.60. So I can't just say just tickets. I got to say, like, I'm going to let A be the adult tickets sold because there's no guarantee that I'm going to sell the same quantity of each one. So A can be the adult tickets, Y can be the youth tickets. And now let's go to town. $16.60 times A will tell me how much money I get for the adult tickets. Plus, I'm going to charge $12.20 times however many youth tickets we sell. That will give you everything inside here is how much money you're going to totally raise by selling the tickets. Then the band gets 25% times that whole chunk. All right. Okay, now to simplify this, what we could do is take that 25/100ths now and distribute it times both things. 25% times $16.60 would be $4.15 times A, and then take 25% or 0.25 times 12.20 times Y, which would be like 3.05 times Y. A and Y are different letters, so this would be how much the band gets. Inside the parentheses up here is how much total money you take in, but the band gets 25%. Hope they sell a lot. All right, let's take a look. What I want you to do is pause the video and use the distributive property to simplify each one of these. On your mark, get set, go. How'd you do? Did you get them right? Watch your signs and go from there. The last few examples are going to be factoring ones. This is where you're going to work backwards from the distributive property. So I see 4x plus 8. I want to break it up as a multiplication problem, as something times something else. One of these things is going to be in parentheses because you have more than one term. 4x and 8. What do 4 and 8 have in common? Well, they do have a 2, but go more. Get the greatest common factor there, which should give you a 4. What's left when you factor a 4 out of 4x? 1x. I like to write the 1 there so that when I multiply again, I'm thinking, yep, 4 times 1. Factor a 4 out of that plus 8, and you should get plus 2. If you went and redistributed to check this, you end up with 4x plus 8. All right, here you go again on your mark, get set, go. Pause the video and see if you can factor each one of these expressions. I heard one of my classes say today, this is way easier than doing the distributive property. I said, what? Are you serious? That's a great, nerdy algebraic thing to say. Cool. I love that. All right. Factoring, distributing, adding and subtracting, you're doing all kinds of fabulous things with algebraic expressions. Check on Schoology for your assignment. Good luck, and may the force be with you.